Velkommen alle sammen. Jeg heter Bjarte Brandt. Vi kan ta denne sliden først. Ble ansatt som DevOps-arkitekt i TV2 i september i fjor. Jeg er også medlem av Oracle User Group Norway. Har drevet med Oracle i en årrekke. Etter at jeg begynte i VSAT og tok tak i databasen der og har jobbet med Oracle-teknologi hele veien frem til jeg gikk over på automasjon og tenkte at det var veldig spennende.
Just one question. Is it possible to do it in English?
It is possible to do it in English. Actually, I was asked, but I forgot. Sorry. Basically, I got interested in automation, and for a long time I worked with Oracle technologies, and now I'm into all these kinds of technologies on the right side there. So let's continue. I'm going to present a live demo, so let's start with the demo. I'm going to tell you a lot more about it. Yeah, you can see this. I have some scripts prepared. I am going to create a Kubernetes cluster on AWS. And I have to initiate my environment. And I'm going to provision a Kubernetes cluster. It's going to take 15 minutes, I think, on AWS. So here I have all variables I need in order to provision the cluster. So just going to check. I'm going to delete my GitHub repo. You see here I have my GitHub token. It's not visible, so you can't delete my GitHub repos. If you had the token, you could have done it. So I'm going to delete it. Now my GitHub repo is gone. And finally, I'm going to create the cluster. I'm going to explain all of this a little bit later. Create cluster. So let's wait 15 minutes. Yeah, I can explain how the cluster is provisioned. I'm using a tool, open source tool called COPS. It's available on GitHub as well. I first have to create, first of all communication with AWS, I'm doing it through the API and through this tool called AWS. It's a client tool where you communicate with a cloud provider. All cloud providers have client tools to automate all kinds of things in their cloud. So AWS, I'm creating a bucket where I keep the state of the cluster, and I'm not going to create snapshots because it's a nightmare to delete the bucket afterwards if I create snapshots. You first have to delete all the snapshots inside the bucket and then delete the bucket itself. When I looked into it a long time ago, actually, I couldn't find a solution easily. I'm sure there is. And COPS create cluster. You provide availability zones. This cluster is just a demo cluster. In a production cluster, you would provide 3 zones. You specify the size of the EC2 instances on AWS. Are you all familiar with AWS? Yeah. And the node size, how many nodes, domain, and the key, how to access it, and the version. I think the latest Kubernetes version now is 1.11 or something like that. I think 11 is an alpha. And yes, and there you go. So, going to give you a short introduction. How many of you are working with containers today? Cool. This is what we are going to solve. This is what we solve with containers. It's really hard to ship thousands of software packets to all our servers. We have tons of servers, and we need to update them and modify and maintain all of this. And containers help us isolate this problem into smaller problems, and that's the reason why container technology has become such an important technology. Traditionally, we use virtual machines. I'm going to briefly just talk about this, but the thing you see here is that there's this Docker layer which communicates with the kernel and the libraries, and then you have the application. Containers are very lightweight compared to virtual machines, where you have the guest OS and the libraries and the application. So 10 years ago, actually, container technology on the Linux kernel was possible. You see here, it started in 2002 by probably, I'm not sure, but probably Google. But you have Solaris and FreeBSD. There has been tons of container technologies around long before Docker came along. But there are two very important things. Namespace, we need to isolate the application. And we need to control what kind of resources the application can use. So the combination of namespace and C groups, that's the story behind that enables container technology. But there is one more thing, and that is the file system. Because we need to have a lightweight file system where we I'm going to put this. They have developed this copy on write has been there for a long time, but the file system used by containers are some way copy on write, a union file system where only increments are added, and so you save tons of space. One thing is that if you have actually the container file system is of course very important, and there are some older file systems where, let's say, if you put a really big file on this layer and you modify it, you will have to copy it to this container layer, and then you can write to it, and you add a new layer on top of it. It's going to take. It can be a very costly operation. So the union file systems, and now there are tons of other alternatives. Red Hat has some, and all the different file systems can do this copy on write. And I've just found this drawing here, and Windows has also container technologies. One thing I noticed was this compute service. They have this layer here on top of the control groups, the namespace, and the layer capabilities of the file system. So that was, I think that was, yeah, that was it about containers. Now I'm going to talk about how do we operate containers, how do we deploy them. The way we do this, now I need, wonderful, let's see. Just hold on. Oh yeah. Okay, this is how we deploy containers at TV2 today. We develop our code on our laptops. We push it to GitHub and Bitbucket. Then we Jenkins takes over and compile and do all the CI, continuous integration, continuous deployment. And the container images, they end up in Artifactory. And from there, we use this configuration tool called Ansible, where all our infrastructure is described and all our applications are described. And we provision to all our servers. And finally, we provision the containers on those servers. So this is a really effective way of provisioning software to our servers. Ansible is really a good tool doing this. So if there are questions, you can please raise your hand. There's
maybe can you talk a little bit about the what's it called, Artifactory? JFrog.
Yeah, JFrog
The most unknown tool here for me at least.
Yeah, JFrog Artifactory is a service. You can compare it to Docker Hub. This is the place where you store your Artifactory. An Artifactory can be an image library or Docker images, anything that has to do with your application.
Basically build output.
Build output. Yes, because all the binaries, etc. You know, it's inside the image of the container.
About Artifactory, that's just a place to store artifacts, so any kind of binary or anything. You can use it as a Docker repository. It could also be just binaries from a build, but the way we use it is that it's just a repository like Docker Hub for your images.
Yeah.
Thank you. Any more questions? Are you familiar with Ansible or SaltStack? There are tons of automation tools. Ansible is a configuration management tool. Cool. So, what are the problems with this solution? The way I see it, where are my containers running? It is described in the Ansible YAML files somewhere, but it's not easily accessible. You have to know Ansible in order to figure out where your containers are running. How much resources do they use, etc. We do a lot of, we visit too much standalone hosts to figure out the status of our containers. We log on, Docker, PS, Docker log, etc. to figure out what is going on this host. So these are problems that right now exists. So we are looking into Kubernetes. Kubernetes, it's a quite funny name. I went to the Greek Pi in Valkenovskatten and asked the guy there, I wanted to order a Kubernetes because he's Greek. And Kubernetes is an old Greek word. but he he didn't understand what I was talking about. He had never heard the word, so it's new to us as well. Funny name. It means helmsman. You know, the guy in front of the troop. Cool. So this is what we want to solve. It takes forever to provision all our infrastructure. We don't have time for this. We need to focus on our applications. We need to bring our applications to the market. Overview of where are your containers, resource, monitoring, and we want to focus on our applications. And of course Kubernetes can do a lot of more things. I'm going to talk about that. What is Kubernetes? Open source system. How many of you have actually installed Kubernetes and tried it, played with it? Yeah, quite some. Great. You know, there are tons of information on internet. This talk is not going to, we're not going into all the details of Kubernetes. There are tons of information on the internet. This talk is we're gonna see how this works, and hopefully this will give some value. Because everything else you can read on the internet. But basic concepts, we have pods, can be one container, usually it's one container, but if they have dependencies, for example, you can have several pods, several containers in one pod. Labels and selectors, they're really important to control the traffic in your cluster. Where is we are exposing a service. This service is built on these pods, and you can define that with labels and selectors. And you have all these different API objects inside the cluster. And you describe the API object using a YAML file. So it is the same as we do with Ansible. You describe the status of your application's infrastructure. Not the status of your application, but the status of the configuration of your application. And of course, you describe it and you source control it, so you always have ways to go back and to see how your projects evolve. Typically, when you launch an application, you create a deployment API object. You describe how many pods, because you want to load balance, you want to be high available, you want to put them on several nodes. And a deployment contains a number of the pod type, or the type of container, and how many replicas of that container, and it will scale out to your configuration. Services, this is where you expose your application. You can have, first I'd like to say, if you have an external database, let's say you have an Oracle database your containers needs to access, you describe a service, external service inside your cluster where this service points to the Oracle database. So all your endpoints can be in the cluster. Very nice way to do things. If you describe a service to be a load balancer on the AWS creates the load balancer for you. So you can access it. I'm going to demo it. And there are tons of more API objects. Stateful set, if you have some stateful service in your cluster, Oracle, MySQL, Redis, Kafka, anything like that, you use stateful service to make sure you take just one down, one node, and this stays down, and all the others stays up. And you control the way you, for example, upgrade your stateful service. And daemonset controls, it's related to nodes. You're going to put this service only on this node. So I'm going to show you let's see if this comes back up now. We need to see a Kubernetes cluster. That's our next topic here. I have yes.
There's probably many here that are new to orchestration of containers. Perhaps we should explain the difference between Ansible and Kubernetes. Why Kubernetes does something you would otherwise have to do explicitly. What is the difference between configuring an environment and having to orchestrate it?
Well, in Ansible, you specify the node where you're going to put your containers. This is something we don't want to know this. We don't want to work with operating systems. I don't want to know where to put my my containers. I just want to deploy them, let the cluster take care of where there are least resources available, and deploy it to that node. So this will simplify things. Now with Ansible, we need to make sure our containers are running on this node and this node and this node, and we also have to configure the load balancer on top of it to point to this and this and this. Kubernetes will help us with this automation. I don't know if you can please add more if you.
Basically in Ansible, you are explicit. You have a set of service and you have a set of containers. I'm deploying this container to this, and this server. And then you have to set up the load balancer to point to those three servers. If one of those servers goes down, you have to explicitly tell it to go on a different server. You have to actually do that action. What Kubernetes is doing for you is you say, I have this set of servers and I have an application running in a container. This container should be deployed on at least 3 nodes. So it's up to Kubernetes to make sure there is 3 running across your infrastructure. You don't have to have the relation to where it's actually running. And Kubernetes does some other things like service discovery, internal DNS, load balancing, making sure you're only deploying containers on nodes which have the capacity to run them. If a server goes down, it will move it to a different server, and takes care of all this orchestration you would otherwise have to manually change configuration to deploy. So it does it automatically instead of being explicit about where it ends up.
Excellent, Erik. Before we continue, I'm just going to show you a live Kubernetes cluster. Not on AWS. I have created my own on in Vagrant. You see here I have a master node and a worker node. I'm just going to show you now. Hold on. Okay, this is how we install it. Just going to show you some short. We used a tool called called kubeadm. It's still in beta, and kubeadm can only provide one master. So it's not, it cannot be used for production right now, but it's rapidly improving. But basically, this is I have two Ubuntu servers, and there are not many lines to provision a Kubernetes cluster. So this line, kubeadm init, and kubeadm join on this line. That's how you do it. And if you have a new node, you can add it and you just join it in. So what I was so I'm going to log on to the first of all, I can show you this is how we communicate with the cluster. kubectl get pods. No resources found. There is nothing on this cluster. But that is not true, because if I do namespace kube system, this is the software behind containing the cluster, and our applications will not have access to this namespace because it's isolated. But I have added a dashboard. You install it just by doing kubectl create and file and dashboard YAML, something like this. So it is installed, and we're gonna look into the cluster. I need to find my cat dashboard setup. I'm going to proxy onto this cluster to have a tunnel. Yes, what I need to do is first I need the token in order to for my admin user. It's a really nice command. I love this token. And let's port forward on. So now we do port forwarding. I need to suspend it and I bring it to background to okay, and then I take my token. I'm going to log in. Let's go to HTTPS. It has to be HTTPS. Localhost. Do we have the port? Here it is. I have my token. Yep. So now we are inside a Kubernetes cluster. Here you will find all the objects, services, namespace. When you provision applications or containers to this cluster, you can define one development namespace, one production namespace. You can have them isolated inside this cluster. And yeah, you add storage to it, secrets, where you have your passwords. And ingress is also a pretty complicated API object where you configure the access of the service, typically in your on-premise infrastructure, where you don't have this, where you don't use this load balancer feature on AWS. Ingress is also a lot more sophisticated, where you can terminate HTTPS or SSL traffic and do all kinds of routing. And here you have pods. Let's bring on a pod. I have some YAML files here. I have an alias key. It's called kubectl, just as you know. Kube, get pods. We have nothing. Kube, create, and then we do a test deployment. Okay, get pods. Okay, it's creating, and I can press this. I can add wait. Now it will pull the image from, probably it is from Docker Hub. We can have a look at the YAML file. Test deployment. We have an image called Python 2.7, and what we do is just do bin bash and hello from index simple HTTP server. That's our deployment. So we are going to access this service using adding our service API object. Okay, create test service. So let's have a look at the service, test service. This is the name, service test, selector, service test pod. This is going to find our service test pod. Here. And let's see, and we will also access it by our client container. We have test client 2. What we do is I just do an echo get, use netcat, and this is the name of the service. If we go here now, we should see the service. Sorry, service. Here we have our test service. And we have 2 running pods. Let's see if that is correct. Okay, get pod. We have 2 running pods. And option wide. We can also see their IP addresses. So the thing is now, both of them are running on our worker node because we have only one worker node. So let's access this service by creating create and our test client. So what this just accessed port 80 for our service test. Let's see if we have a response. Okay, it's completed. Okay, log and the name of our container. It says hello from service test. So this tells us that the service is an abstraction for, it's a virtual name for our pod, for our containers. Okay, fine. We are done with showing a live Kubernetes cluster on my laptop. Just going through the architecture of Kubernetes. We have our nodes. Like I showed you, you can just join in nodes. You can have, I think now the latest read in the, how many nodes? It was like, they were working on scaling it to 100,000s of nodes. So that must be Dropbox or something. I don't know. Okay, developer, I access this through this kubectl tool, API server. We have this etcd developed by CoreOS. It is a service where the state of the cluster is stored. Very important component. Now CoreOS was acquired by Red Hat. So let's see what happens with CoreOS. CoreOS has become a big player in the cloud infrastructure environment. The controller manager is responsible for almost anything that goes on in the cluster. And the kubelet is the agent on the node. It is responsible for making sure there are 10 pods available. If the cluster was instructed to create 10 pods on this node, it will do it. And kubeproxy will handle the network between all the different nodes in our cluster. And the scheduler will make sure that, for example, 10 replicas should be scheduled to these nodes, and it will instruct finally the agent to do it. And typically, this is a typical operation on the cluster. You create a cluster, you deploy the app, you can explore it, and then you expose it. Because initially, when you add your container, it's only available inside the cluster. And you scale it very easily. I'll show you. Then you update your application. Before we go on to the demo here, here are some big players on the market. I recently installed Tectonic on my laptop, and it has basically the same. It looks quite the same as this, surprisingly. And Red Hat has had huge success with OpenShift, which is a container Kubernetes cluster platform. Can run in their cloud or on premise.
What's Tectonic?
Tectonic is it is CoreOS Kubernetes product, licensed product for it's their Kubernetes cluster product.
So why would you use that instead of Kubernetes?
That is a long discussion. Depends. How much support would you like? You know, this is on the web page it says, please contact your salesman to get a quote. It's more like Oracle.
So if you have a lot of money, you can use it.
Of course. This is one of the, I think, running Kubernetes cluster in your own data center. This product is probably one of the best. Also, OpenShift is another product, especially in your own data center. But now there are other offerings. You have Amazon with their Kubernetes offering in the cloud. It is not launched yet. It is launched, but it's not publicly available. But they are working on it. I know Azure has its own, and Oracle and IBM. But we are going to use this COPS open source tool to manage our own cluster on AWS. So if we use this tool, I have to make sure how my cluster is upgraded, for example. I have to read tons of documentation how this works, how the upgrade works, how to add a new node. I think COPS is a great offering for many, but companies have to decide what tools they would like to buy. If they want to do it all by themselves, or if they want to buy a service and products.
Just basically, Kubernetes is a huge open source project, and you may use tools like COPS to deploy that open source project. Otherwise, you can choose, for example, Amazon EKS or Google Kubernetes,
yes,
or Azure Kubernetes managed service, where you just want the cluster, you tell them you want a cluster of this size, and they take care of all the provisioning of the cluster. Additionally, you have like all these different other proprietary solutions to how you can actually deploy a cluster. But the underlying technology is the same. It's the same open source product, just with different ways of installing and maintaining the cluster.
Yeah. So now we need to go to our next slide. So now we're going to, I'm going to show you how we provision a real a blog application, and how we update it, and how we do Canary releases. So, yeah, demo our blog site. Are you ready? How many of you have seen Hugo? Only one. It's a great product. I see there is one Norwegian very active in the community. The world's, no, it's not me. The world's fastest framework for building websites. Because we're going to build a website, we need a framework. There are millions to choose from. All right, this is how you create, how you use this framework to create a blog site. And we push it to GitHub, and we build our images. This is how we do it. How many of you, yeah?
Might mention what Hugo is, if you didn't already.
Hugo is the world's fastest framework for building websites.
But it's a static.
Yes. For building, yeah, for building static sites. You know, there are no moving parts here. No database connection, nothing. Everything contained.
Basically transforming Markdown files to HTML.
Yeah. There are other static frameworks. I heard some, it's called Jekyll.
Yeah, I think that's used by GitHub to produce their...
Yeah, it's there. Tools like that are really good at creating documentation. All right. How many of you are familiar with Docker files? Okay, cool. This is how you describe your Docker image. And you use a base image. I'm using Ubuntu. I try to use Alpine. You know, there are 100 million different base images. I would love to use Alpine, Ubuntu Alpine, because it's much smaller. The problem with Alpine images, I have issues with the network. It takes forever to download them. I think there's the firewall and inspection going on. I have to talk to network. So I want Ubuntu, and I need only these, not only, I need these three tools. We got Git and Nginx. Actually, I should have it would have been much nicer to just use the Nginx base image. And then we need Hugo. That's the procedure how to download Hugo and install it. Move Hugo, the binary, to this location and delete the install file. And inside, isolated inside my my image, I clone my application. And then I put all those HTML files from my application to this directory, and then I fire up Nginx. Very simple. But you have probably done this tons of times outside a container. But now we're doing it inside, isolated inside the container. Cool. So this can't go wrong. This will work. When I deploy this on my Docker framework, if it's CentOS, Ubuntu, whatever, it's gonna work for sure. That's the real advantage here. There will be no library dependencies problems because it's isolated. And I push it to Docker Hub. All right. So, hold on. Now to the demo. So we have, I'm going to reset first. Let's see what it does. Yeah. Okay, I'm going to explain this a little bit first. We have been through the environment. We don't know if our cluster is running. We probably should check that. I can do it by just going to validate if our cups validate cluster. Let's see if it works. I call it CO1. It is running. I have one master node and two worker nodes with T2 minimum. Can I communicate with it? Let's see, get whatever, get pods. Oh yes, let's see if I have everything else in place. Cube system. Yeah, it's looks nice. So we have created the cluster. Now I'm going to create our application. Before that, I'm just going to check what. I'm just going to remove my Cube app application. That's my blog application. It's here. So yeah. And it deletes my repo. I've already done that, but fine. Let's do it. Not found. Okay, not a problem. So now we are going to create. How much time do we have left? 10 minutes. Let's go. Okay. Let's create our first blog app deployment. Press enter to continue. So now I have deployed. Just need to read here what I'm doing here. Okay. I think live demo, but let's see if this works. What I'm wondering is I should have downloaded, but I can stop it. Let's see. Create application. This is what I would like to do. I'm going to create the posts. Why? Create GitHub repository. And it's, sorry, I run 03. My mistake. 02. Create application. Okay, let's create GitHub repository. It's done. Create our web application. I'm creating my web application. I'm going to show you GitHub. Here we go. Let's see if it's Cube app. Here is my my Hugo application, and with I'm going to showing this Canary release. I'm going to manipulate my application by showing two versions of my application with theme 1 and theme 2. So now I'm adding theme 1 to my application, and I'm building an image based on theme 1. So my application will have two types of expressions, and I'm going to switch between them. So now I'm building the Docker container from the base image Ubuntu. And I wanted it. Now it's updating the image, and it will install the Hugo application, and it will pull or clone from GitHub and create. Now you see I'm downloading Hugo, I'm cloning it. You can see all of this, yes, cool. And I created my Hugo application and moved it to www.html, and now I'm pushing it to Docker Hub. Let's go to Docker Hub. Yeah, this is where it's going to end up. I have a few seconds ago. This let me just refresh. It's hold on. Now it's pushing my big 100 megabyte image to Docker Hub. It's going to take some minutes. Any questions? So if I've had Alpine or just use a smaller base image, this would have been much faster. Okay, and this, now I pushed the T1 image. We can see that. I'm just going to press enter. So now if we do, a few seconds ago, I have created a theme 1 image of my wonderful blog application. So now I'm building theme 2 of my wonderful blog application. So it actually goes through the same process, but instead of including theme 1, now it includes theme 2. We can also go, while we're waiting here, we can also go to AWS and see how things look like here. This is my account on AWS. Oh, forget it. I have to sign in. Okay, I can do it. you know, I'm communicating through the API, but here's my cluster. 2 nodes, 1 master. The last one, forget it. So they are automatically provisioned for me. Now it's pushing my T2 theme. How much time have we got? 3 minutes. Okay. I think we should just go directly to the Canary release. You will get the point. You see, the layer already exists. So this layer is, let's see. Another thing, you know, I'm working here with EC2, where I have my AWS instances, my computing power, and I also have to operate Route 53, which is AWS DNS service. Because eventually I need to access this, my wonderful blog. All right, so let's go directly to Canary release. I'm going to do it like this. Cat 05. Yeah. I don't need to create those files. I'm just gonna deploy my blog, and this line is going to Control C. This line is going to create the load balancer for me. And now this load balancer has an address on AWS. And I need to create a DNS entry for this balancer. So I'm just to make sure here, I want here is the address of the load balancer. Just to make sure, cube app ELB. There it is. I update my DNS like this. And it says create update a CNAME record. We can now move on to Route 53, and I have a domain name called ripple.no. I don't use it for anything. I just have it. And I have a cube app ripple.no. Let's see if my application is available. It says pending, but we can try. Are you ready? Cube app ripple.no. Can take some time. Here we can, of course, you can do a lot of things with kubectl. You can describe your deployments, your pods, your service. You can describe anything. Let's see if it comes up now. I'm going to try it in different browsers because maybe there's a plus sign here. Cube. Okay, but here you have the CNAME, and here is the load balancer address. Let's go to EC2. Let's go to load balancers. Load balancers. There should be one here. Actually, 2. Let's see if I. And they are attached to those two nodes here. So it should work. Interesting why I have two. But they have, okay, it's 19 and B6. Let me just check if both of them. Sometimes I have to wait a little bit longer. Let's go back to Route 53 and here you can learn some AWS as well. It says 19, so, and there were some services underneath, so it should work. It works! Okay, I have my two blog posts. I have kubectl and handy bash one-liners. I should have replaced the entry image with something else, but there was no time. But cool, I have an application, and now we are moving on here. I'm launching my other theme. All right, okay, get pods. Let's see what's going on. It's creating containers. I have 6 versions of Cube app theme 1. Actually, we can do this. This 25% is probably not correct because I've played around with it for. Now we should have 50% possibility of. Let's see here now. Okay, okay, the problem was that I run this 02 script, but it doesn't matter. Okay, we should have 50% chance of hitting theme 1 of this application and 50% possibility to hit our Canary release here. Just gonna point out something, and that is this is our deployment description of our application. You see here the track is stable, but the app, like I said earlier, the labels are very important because the service will hit Cube App Canary. This is our service. It will hit Cube App Canary. And I have 2 deployments, and I have told this this deployment, the name is Cube App Canary. It will now attach to the service, like this one, the stable. I should have named them T1 and T2, but whatever, stable. So now the service will route the traffic either to the stable version, the theme 1, or the Canary theme 2. Let's see if this works. All right, I have a new theme going. And now I'm back to the old. I'm pressing refresh all the time here now. So I have 2 different versions of the application running. I can, if we have time, we can scale it. I'm not sure if should I wrap up or whatever. If I scale it down to 0, one theme will not show up in the browser. So then the other theme will show up all the time. So you can control this the way you like it. I think that was an introduction to how you use the Kubernetes cluster, how you can manipulate your sites. So are there any questions? We can take them afterwards. So, and time is up. So thank you so much.
So you actually use this in production activity?
No, right now no. But we are
Soon.
we're soon. The sooner the better.
Is it possible to mix on-premise and cloud using this?
Not in the same cluster. But